Hello, this is Mark Scythian, FAA licensed aerospace technician, airframe, power plant, and avionics certified. The date today is July 5th, 2016. In this video lecture, we will be discussing the true power output of a turboprop engine. Like with any type of gas turbine engine, it always starts with a gas producer spool. You have a set of compressor blades on the front of the spool connected by a shaft to a set of turbine blades on the rear side of the gas producer spool, also known as the November N2 high-speed spool. Inside of that spool is a hollow coarse shaft, which accommodates a second spool, which is a solid lower speed spool that runs through it with another set of turbine blades behind the gas producer turbine set, and another set of compressor blades that are low speed connected to a gearbox, then driving a propeller. So on the application of turbine engines, you always start with a gas producer spool. However, what you do with that thermal energy that's released then becomes the application. If you simply accelerate that hot gas out through a nozzle, then you get the jet. If you put another set of turbine blades to drive a ducted fan, then you get the turbine-driven fan. But in this case, we're dealing with the turbine-driven propeller, which is an open propeller. And so after the gas producer lights off, the thermal energy that's released in the form of hot gas propulsion is then absorbed by another set of low-speed turbine blades, which then rotates a low-speed compressor to assist in the compression, but more importantly, it goes to a planetary gearing system, which then steps down the RPM and speeds up, increases the torque, which is then connected to a propeller. Now, on a turboprop, the blade pitch will change. It will be at low pitch on climb and takeoff, and then as the speed of the aircraft increases, the pitch will increase to let more oncoming airflow bypass the propeller blade. So then you need the torque more than the RPM, and you can go at high speed, lower RPM propulsion. But remember, on the turboprop, the fuel control unit is also in parallel with the blade pitch angle. So at a low pitch angle, the throttle or the fuel power will be high, and then as the pitch increases for high speed, low RPM rotation of the propeller, then the power will decrease, but the torque will remain optimal for that type of flight. So the only limiting factor to how fast a propulsion engine or propeller can go is how much acceleration speed of the air takes place. So on an open propeller, you don't have that much acceleration of mass air, so you're limited in the amount of speed you can travel. Even if the thrust output is very high, the jet velocity or the propeller discharge speed behind the propeller is a lot lower than a jet or a ducted propeller inside of a duct that constricts the cold airflow and accelerates it. So with the turboprop, they're most efficient at 300 miles per hour. You see them on commuters. Now, it's very important to know that all the gas turbine engines, it's nothing but a high-speed gas producer spool where you have a set of compressor blades connected to a set of turbine blades with a combustion chamber in between it. Now, the gases that slip past the high-speed turbine then are channeled to another set of turbines to turn that hot gas thermal energy into torque and shaft horsepower to drive some application, in this case a propeller. So the turboprop is kind of unique because it is something like the turbofan, where you have both propeller and you have some jet thrust coming out, but because it's an open propeller, you have to calculate two variables. You have to calculate the shaft horsepower to the propeller, and you have to calculate the thrust horsepower in the form of hot gases that escape past the low-speed turbine. So in terms of true power output, you have to find out the specifications in brake horsepower for cruise speed, and then you have to also find out the net thrust during cruise speed and calculate or convert that into thrust horsepower. So when you add the brake horsepower and the thrust horsepower, you get the output power. and then you can divide that into the pounds per minute fuel consumption converted to mechanical power as the input power. So the true power output, again, is about 22% brake thermal efficiency when in cruise, but you have to consult with the specifications of the turboprop engine. So again, the turbine-driven application is always starting with a gas producer, and then whatever you take that thermal energy and channel it towards, that's what the application becomes. So on a jet, it's pure gas flow acceleration. On a fan, you're doing kind of like what the turboprop is, except the fan is ducted and the propeller blades are fixed pitch, but you're swallowing up a lot of air and using the torque to compress that cold air and accelerate it out to higher speeds than an open propeller. So the turboprop is kind of part shaft horsepower and part net thrust. So when you get those variables and you make the calculations, figuring out what your compressor horsepower is, if you look for the other videos in this YouTube channel, you can learn how to calculate the compressor horsepower. But that's the power you lose to keep the engine running. You got to focus on what discharges past the high-speed turbine in order to know what kind of shaft horsepower you get out to the propeller and whatever you have left in hot gases out of the exhaust nozzle. Now, some turboprops, they can also be used in the shaft application where the nozzle for the exhaust, it's converging, it is removed, and then a divergent nozzle is used. That would be on a pure shaft horsepower application, like for running a ground electric generator, and that would be a pure torque application. But the same turbo shaft can be converted into a turboprop, and then there's some similarities to the turbofan, but it's an open propeller with a blade pitch change mechanism on it that's linked to the fuel control unit. So all in all, you have two dynamics going on, one with thrust and one with shaft horsepower converted into propeller thrust. And so they're separate. So now the easy way to find out the true power output is to consult the specifications of the turbo shaft engine set up for prop. So it becomes turboprop. And then you know how to take the variables like as if it was a piston engine's shaft horsepower, brake horsepower, and then it was also a jet. So you can add those two together to get the true power output and divide it by the overall power input in the form of burning fuel, kerosene jet fuel, pounds per minute consumption, and then it's 18,730 BTU per pound for kerosene at 6.75 pounds per US gallon is the fuel density, and then 1 BTU out per minute in the form of burning fuel heat is 17.6 watts. 746 watts is 1 horsepower. You can figure out the efficiency and the true power output, but there's kind of a fine line in similarities and differences between the turbo shaft and the turboprop and the turbojet. The turbofan, turboprop, and turbo shaft have similarities, whereas the turbojet is kind of all pure gas propulsion. So in the next video, I'll focus on the true power output of the turbo shaft only for shaft horsepower applications in non-aerospace applications like turbine electric generators, turbine driven gearboxes, etc. But it's important to know that all the turbine engines start with a gas producer, and then what you do with that thermal energy can be channeled to a second spool of turbines to convert that into shaft horsepower and or thrust partially with the shaft horsepower. So that's the overall true power output of the turboprop engine, explaining the dynamics and the principles. But the major understanding of the gas turbine engine is that gas producer spool, and then what you do with that thermal energy can be turned into just jet propulsion, or it could be sent to a second lower speed independently rotating spool that's coaxially interfaced to the high speed gas producer spool with a hollow shaft and a solid shaft going through them. So you have two sets of spools turning. In the case of the turboprop, you're taking advantage of the torque from the hot gas propulsion, but with an open propeller and a blade pitch change mechanism governed by speed of the aircraft. Thanks for watching this video and have a great day.